IP Networking Basics, part of the Dante Certification Program, Level 1, Section 2. In this section, we'll cover some very basic, essential networking concepts and help to clarify things that many audio professionals wonder about. How much networking do I need to know? This is the first question that many audio professionals ask. When a new technology arrives, they naturally want to make sure that they understand it. And fortunately, the correct answer here is not very much, usually. As we'll see, modern networking standards and Dante work together to make most setups incredibly easy. Let's start with the physical side of networking. From a networking perspective, most Dante systems are small and simple, and they're usually just doing one thing: passing Dante audio and control. There are really just three types of objects on that kind of a simple network. The things that you connect, in this case, audio devices and probably a computer or two. A switch or switches. These act as bridges that connect everything together for us. And then finally, the cables that connect them. Let's start there. What kind of cable is used for Dante? What's appropriate? This question comes up really frequently. And the answer is the same cable that you'd use for any network. Audio traffic isn't special, it's just data. And since gigabit network speeds are recommended for Dante, that means using Cat5e or Cat6 cable. Cat6 is rated for greater noise resistance in electrically noisy environments, but Cat5e will work just fine in the vast majority of situations and is the most commonly used. All copper Ethernet cables are limited to runs of 100 meters or less between switches or devices. What about Wi-Fi? We're often asked about that. Isn't that just another medium for IP connections? Yes, it is. However, Wi-Fi differs a great deal from wired Ethernet. At present, Wi-Fi is not yet capable of supporting the low latency and dropout-free performance of Ethernet cables even under excellent conditions. And for this reason, Dante devices will not recognize wireless networking as a valid means of connection. You may use Wi-Fi to connect a computer running Dante controller to a Dante network. All control functions will work over Wi-Fi. It's just the audio that won't pass. What about fiber? Well, really, since fiber is just another way to do Ethernet, the answer is quite obviously yes. Fiber has advantages with distance. It can go several kilometers as required. However, fiber requires switches that have fiber connections, also known as small form factor pluggables or SFP switches. Switches. Always a big topic, but in many ways, they don't have to be. As previously mentioned, a good way to think of a switch is as a focal point that connects all your network devices together. And you can get switches to fit your needs, from very small to very large. Modern switches are smart. They contain mechanisms that allow them to optimize traffic in many cases, and they allow all the ports to go full speed all the time, in both send and receive directions at once. We strongly recommend that you only use gigabit speed switches. That extra bandwidth makes your life a lot easier. There are two basic types of switches you can buy: managed or unmanaged. Unmanaged switches are less expensive, and they offer no adjustments or settings. They're strictly plug and play. Managed switches offer many different options and adjustments, and Dante works with either type. So, which one should you be using? Well, nearly all the adjustments offered by a managed switch pertain to mixed environments, in which you combine audio and other data, such as a business that uses one network to do everything. If you're working with very heavily loaded networks or putting Dante on an existing shared network, a managed switch will likely be necessary. Managed switches can help you with troubleshooting, such as checking bad cables, and have tools such as a web page that can report packet errors on a port. However, it turns out that either one can work just fine. If you're implementing a small audio-only network, you can probably use an unmanaged switch with no problems whatsoever. Now here's another helpful thing to know. If you are using just one switch to connect your Dante devices, and you're only using the network for Dante audio, all of which is an incredibly common scenario, then you don't need a managed switch. The features that management offers simply don't apply here. It's very common for small Dante systems to use only this one switch, and the settings that are recommended for very busy or mixed-use networks simply aren't needed under those conditions. You can safely use unmanaged switches in these small networks. A special note about green or energy-efficient switches. The way that many are implemented may cause trouble with audio and other real-time media systems like Dante. This is especially true when connecting switches together because they shut down ports. In general, it's safer to disable or avoid switches like this in the future. In early digital network systems, or transports, you may have used a daisy chain topology for connecting your devices. This made sense in the analog days, as we thought of each device as contributing some function in series with others. The mic goes to a preamp, which goes to some EQ, which goes to a mixer, etc. This can be done with network products that contain switches in them. The data hops from one switch to another, which is very convenient for small sets of interconnected devices. However, this type of topology doesn't scale very well, as each hop incurs a potential latency penalty. Too many and you can't achieve low latency at all points on the network. How many? Well, in most cases of well-behaved switches, each hop imposes a very small penalty, typically several microseconds per switch hop. However, the latency settings in Dante are based upon worst-case assumptions, and thus are quite conservative. If a daisy chain is desired, we recommend that you test it to ensure that it works with the gear you have. And the primary problem with a daisy chain isn't latency, it's that the failure of any device in the chain will break connections to devices further downstream. In general, switch networks are best thought of using a star or hub-and-spoke topology. In such a setup, all devices on a star are connected to a single switch. If any one device fails, the others continue to communicate. As the network gets larger, additional switches may be brought in to extend the network. This method is generally how a network engineer would connect computers for very similar reasons, and it's what we recommend for Dante. The diagram right here is a good example of a star topology in a Dante network. All devices, mics, a DSP, amplifiers, and speakers are all connected to a single switch. The switch is the center of the star to which all devices are connected. Note that the physical connections shown here do not reflect the flow of audio in the system. The star topology is easily extended to larger systems. Here are two small star networks that can be joined together using another switch to form a larger network. No device is more than 3 hops away from any other, making this a sensible design choice. And in this larger example, 4 smaller stars are joined together by one switch to form a very substantial network in which no device is more than 3 hops from any other. In this example, we have 32 Dante devices connected, quite a bit for most audio applications, but in fact very small for an IP network. Let's summarize this section. With Dante, always use gigabit switches. Use Cat5e or Cat6 cable. Use fiber when you must deal with very long runs over 100 meters. Use either managed or unmanaged switches for smaller networks. And remember, The Dante-only networks with one switch do not require management features and may safely use unmanaged switches. Use a star topology to minimize switch hops and minimize the possibility of one device disconnecting another down the chain. And avoid or disable green features or triple E features on energy-efficient Ethernet. Let's now think about the logical side of networking. This area is a bit harder to grasp. It's not physical. In analog systems, the wiring diagram went a long way towards explaining what the system does. Channels were physical cables that went from outputs to inputs. But as we've seen in networks, the actual connections are logical. That is, they exist in software. When devices are connected on a Dante network, they communicate to one another by sending data from name to name, connected by software. Network cables are carrying lots of signals for lots of different devices. The wiring doesn't tell you what the signals are or where they're going. Networking delivers data in packets that are addressed and sent to destinations, and that data is reassembled at the destination. Modern networking technology is neutral to the type of data being transported. There's no need for special audio networking equipment. Ordinary IP gear is absolutely fine. I'll give you a word about network layers. When you hear people talking about networking, you often hear them speak about network layers. We don't really need to deal with them in Dante, but let's clear up what some of the fundamental ones are. Fundamentally, each layer passes data to the next. Each one does its job independently, and because it does so consistently, it means that the layers above it don't need to worry about it. They just make a request. In the full OSI layer model, there are 7 layers, but here let's just talk about the bottom 3. Layer 1, the physical layer. This is the actual physical medium being used to carry the traffic. For us, that typically means copper wire like Cat5e or Cat6 or fiber connected to a port. As long as this layer conforms with standards, it freely allows us to build upon it, and that allows us to create Layer 2, the data link layer. This is the layer at which hardware devices may be recognized by their unique fixed hardware addresses, usually referred to as MAC or Ethernet addresses. Devices now may communicate using these numeric values as addresses. Layer 3, the network layer. This is the layer at which devices are assigned variable numeric addresses called IP addresses. Devices may now communicate using these numeric addresses, and the other members of the network don't need to know the MAC address. It's been abstracted away. So this begs the question, what is an IP address? You've certainly heard about it. And an IP address is a numeric value that is mapped to a device. It is not part of the device. It can be changed. A key point is that IP addresses define lines of communication. Devices can only directly communicate with others in the same address range on the network. A device with an IP address different from this defined range will not be able to communicate with the others. So, in a LAN, or standalone network, all IP addresses must be in the same range, and so we need to have a method that ensures that they are. IP addresses can be manually assigned, but this is usually done automatically. They can be dynamic. And speaking of assigning them manually, we generally recommend that you avoid manual, static IP addresses. They are rarely required and often result in problems due to human error, resulting in difficult-to-solve problems, such as duplicate IP addresses or unreachable devices that are out of the defined network range. Let's define some more terms that you've been hearing here already. A LAN. The term LAN, L-A-N, stands for Local Area Network. This kind of network is extremely common. and is typically what we have in our homes with a Wi-Fi access point and a few connected devices. A LAN is a computer network that contains a relatively small number of devices, typically less than a couple hundred. Devices on an Ethernet LAN share a common IP address range, which allows all devices to freely communicate with one another to send data and share resources. On a wired Ethernet LAN, speeds are very high, and reliability is excellent. Typical Dante installations are always on LANs, as are other networked audio installations. And what is a standalone network? In audio networking, we often hear about standalone networks. Well, these are networks that are themselves LANs, you all thus sharing a common range of IP addresses. But what distinguishes these is that they're dedicated to a single primary purpose, and they're not connected to external resources, such as the internet or servers shared by other LANs. They're not connected to other LANs, but they are islands of data traffic. Now, standalone is a technical term, or not really a technical term for distinguishing networks, but is a common method for separating responsibilities. For example, an AV group may wish to have a separate network simply to avoid sharing costs and management tasks with an IT department. If anything goes wrong, it's clear who needs to respond. Well, we've been talking about LANs and the fact that they need a common address range. Let's talk about how this gets done in real life. Because IP addresses are really important to a working network, Dante supports automatic addressing. When devices are connected together, Dante devices will self-assign addresses that create a working LAN with no conflicts. No other components or configuration are necessary. Note that Dante fully supports all common means of managing IP addresses. They can be configured manually, or you can use a DHCP server if you have one. But most Dante systems are standalone networks using self-assigned addresses. Let's summarize some of what we learned here. Layer 3 is what enables the use of IP addresses in networking. And automatic addressing ensures true plug-and-play use of Dante in standalone networks by ensuring that all the IP addresses are indeed part of a functioning LAN. Standalone networks are useful for keeping AV responsibilities separate from others, but they're not necessary from a purely technical perspective. Please continue to Section 3 of the Dante Certification Program, Level 1.